Okay, so welcome back. I'm sure you've watched part one repeatedly and you now understand the two paths that you take, AD or BCE, and we do data sufficiency question. The first example I've written for us here is a yes-no question. Is integer x even? So step one, what we need to establish is the variable. We have one variable, it's x. We have no limits apart from the fact that it's an integer. We don't know it's even. We're being asked to find out yes, no, is it even, is it not even? So from the question stem, there you go. It's a yes, no question. X is the variable, it's an integer, so it's not going to be a decimal fraction, etc. Now that means if we can say that the information in one, both, or either of the statements is sufficient, we will know that x is either always even or never even. That would be sufficiency. But a no, in other words not sufficient, would mean a decision that it's sometimes even. Okay, and there, in this case it would be sometimes odd, sometimes even. So maybe pause the video and realize there what sufficiency means with regard to a yes-no question in this particular case. Step 3, we're going to just look at the first statement by itself. Well, we know that x is an integer, and we know that when we square it, we get an even. Okay, and of course, that's also an integer. The quickest way here is to just try a few values for x. So I'm going to start with some odd values. So let's do 1 squared. 1 squared as an integer is not going to give us an even integer. It's going to give us odd. So because we know x is an integer, we do 1 squared. I'm now going to try a couple more just to make sure. So I'm going to say let x also be 3. So 3 squared. 3 squared is 9. Then 5. 5 squared is 25. So obviously as you get better at math again, you'll realize immediately we cannot use odd numbers here, but we can use even. So for example, x squared is even, 4 is even, 16 is even. The only way we can get there is by having values of x which are even. Therefore, we always get a yes from the first statement. Doesn't matter which numbers we choose, according to the limits of that first statement, we will always get a yes. So we're going down the path AD. Okay. Now, step 4, we look at the second statement by itself. This time, however, it's slightly different. The square root of x is an integer. Now, just with a bit of deduction, you'll realize, well, there are too many options here. It could be odd, could be even, but let's just double check. Let's have a yes first of all. So let the integer be 2. Well, that's the square root of 4. Okay. 4 is even. That gives us a yes to the question. But let's go for a no. Let's say x is 9. The square root of 9 is 3. 3 is an integer. We follow the limit set up by statement 2. But we've got a yes and a no. We've got an option where x is even and odd. Sorry, where x is even and an option where x is odd. That means statement 2 by itself is not sufficient. Therefore, only statement 1 by itself is sufficient. But that means we do not put the two statements together. We only do that when the first statement is not sufficient, and neither is the second. So the answer choice here was A, because we got to an answer choice, we got to a conclusion using the first statement. The next question I put up for you here is a value question. What is the value? Okay, that's pretty clear, but very often just the word what will be the clue that you're looking for. Step 1, what variables do we have in the question stem? We know that x is an integer, so we have the variable, we have the limits. Nothing too difficult there. It's a value question because it starts with the word what, and you'll pick more and more of these clues up as you do more and more questions in data sufficiency, so that's not a problem. Now step 3, as in the previous question, we're only going to have a look at the first statement by itself, so x squared is even. Okay, let's pause for a minute. We know that x is an integer, but hold on a sec. We're interested in a value here. We're not interested in knowing, as in the previous case, a condition of x, whether it's even or odd, for example. There's an infinite number of x squareds out there that are even. Just to follow a system, we'll say, okay, we'll choose an even number 4. Well, 2 squared is 4. Let's choose another even square, 16. Well, 4 squared. So we've got x being 2, we've got x being 4. we've got two values. In data sufficiency value questions, if you've got more than one value according to the limits of a statement, that's not sufficient. So think about that. Pause if need be, but statement 1 is not sufficient. So we're going to go down path BCE. BCE in this case, I'm going to do a third question after this one, okay, where we do actually need to do step 5. But you'll see very quickly from step 4 that because the square root of 16 is 4, it's very quick to say, well, hold on, x is square root of 16 minus 2, x is 2. You don't have to be a genius to realize that, but do follow the process. There are some sneaky traps that come up in data sufficiency. Statement 2 is sufficient because there's only one value according to the limits of statement 2 for x. Now, I've tweaked the question a bit now for a third question. It's still a value question using very similar information from the previous one, but now I'm going to make sure that we have to go into step 5. But let's go through the process. Step 1, x is an integer. That means we can't have any fractions or decimals, and it's a value question. Okay, so that's the same as previous. Next up, we're going to just evaluate each statement alone, and this is where I'm going to go a little bit more slowly, because if you've only just started your GMAT journey, some of this might be a bit new to you. When you take the square root of a variable, you don't know whether the result is positive or negative. So in other words, if x squared is 16, x could be plus or minus 4. Try it on a calculator if you need to. Minus 4 times minus 4 is 16, and 4 times 4 is 16. That means we've got two possible values according to the first statement. That means the first statement's not sufficient. Therefore, we're going down path BCE. Okay? Again, if you need to recap, watch video 1 again, check your notes, whatever needs be. Step 4 here, we're now going to look at the second statement. Well, by itself, as you can see, x is positive. Unfortunately, there's an infinite number of positive integers, so there's no way we can consider that sufficient. So the second statement clearly insufficient. But when we go to step 5 and we put everything together, let's put the information down. We know from statement 1 that x is either positive or negative 4. Statement 2 reduces the limits. Okay, so now, increases the limit. So in other words, we now know that x is positive and it's 4. That's sufficient. So putting everything together, we choose answer choice C. We only had to do step 5 because neither statement was sufficient by itself. There you go. I hope that was useful. If you've got any questions regarding this or any other parts of GMAT, feel free to click the link. Contact us directly or find us on social media. You'll find plenty of other data sufficiency and more quantitative questions, some basic, some much more advanced on our YouTube channel. It's all available for free, so go ahead and subscribe. And of course, on the verbal side, plenty of information coming from us on that as well.